Hi everyone, welcome to this next video. So in this one we're going to be looking at solving simultaneous equations. I've done a video on solving simultaneous equations algebraically, so make sure you're happy with that algebraic side to it. And this one is now solving them graphically. So the other thing you want to be aware of is if you are not 100% sure on how to plot equations of lines, it's worth watching my video on how to plot quadratic graphs and also how to plot linear graphs. Okay, so let's jump straight in. Look at this first of all. So solve the pair of simultaneous equations 2y plus 4x equals 12 and y equals 3x minus 4. First thing you really want to always think about is this. Is it in this format? The mx is the gradient and the c is the y-intercept. So we're going to take a couple of shortcuts here on plotting, but the first thing we always want to think about is whether or not it's in that format. So looking at these two questions, I can see, yep, that bottom one's good. It's in the form of y equals mx plus c, but this one needs rearranging. So the first thing you're going to do is take the 4 over because you want to get the y on its own. So 2y equals 12 minus 4x. Remember, if you're moving something over an equal sign, it becomes a negative if it is a positive. So if it was a negative on this side, it would become a positive, so it changes sign. And then to get rid of this 2, I'm going to divide all this side by 2. So y is equal to 6 minus 2x. Now, although that is not in exactly the same format as this, we can also write that as y equals minus 2x plus 6. Because I just moved that side, that side, but we're not moving it over an equal sign, so they stay the same. So that stays as a negative and that stays as a positive. So now we're happy. We've got that equation, we've got that equation, the two lines are good. I'm going to just underline this one in red because I'm going to do that one in red and this one I will do in green. So let's plot both lines first of all. So we're going to start with this red line here. The first thing to think about, and this is our shortcut on how to plot, is this part here, your y-intercept. That tells you where it crosses the y-axis, and in this case that is at minus 4, so you put a cross at minus 4. Now your gradient is 3. So what you do is you always, from that point then, you go across 1, and what I mean by 1 is one value on your axis. If I went across 1 square, technically that's not, that's a half. So look at your axis all the time. You can see here that on my y-axis, 1 square is 1, but on my x-axis, 2 squares represents 1. So just be careful of the scale. So you go across 1 square. So I'm going across 1, and because my gradient is 3, I go up 1, 2, 3. And then I put another cross at that point. I then follow the process again. I go across 1 square and I go up 1, 2, 3. Put across 1 square, 1, 2, 3. And I carry that on until I get to the end of my axis. And then I can go the other way if I need any more space. So it'd be down at that point there, but that's off the graph. So you can put it in, but it wouldn't be necessary in this case. So that's my red line. I now follow the exact same process for this green line. So this time, what you could do is you could pause the video if you wanted to and try and mentally plot it yourself, or you could write it on a bit of paper or on your notes. If not, just watch me and I'm going to go through it now. So you go to 6, put a cross. You go across 1 square. So again, I'm going across 1, but this time your gradient's minus 2. So from here, I go down 2. So that would be my point. I then go across 1 and down 2. Cross 1, down 2, cross 1, down 2. So that is the point I get to. And you could extend the line all the way through. If you did need to go the other way, you'd go that way and then up 2, because obviously that is the reverse process. So we plotted both lines. We've pretty much done this question now. So now to solve it, remember with a simultaneous equation, you have an x value and you have a y value. So what we're going to do is we're going to look at this point here. This is where they cross. So where they cross is your answer. Now be careful that you write down the coordinates correctly. That is 2. So it's 2 across. Remember, you go x first and then it's up 2. So the coordinates at this point are 2, 2, which therefore means this is your x coordinate, this is your y coordinate, x is 2, y is 2. They won't always be the same, but in this case, they are. Okay, so that's how you solve a basic linear equation with a linear simultaneous equation graphically. Okay, now let's look at when it gets a little bit more complicated. So this one's slightly harder because actually now what we've got is a quadratic So this is a quadratic. Okay, it will give you a U shape because there's an x squared involved. And the other one is a basic x plus 2. It's a basic straight line like we've just done. Now, if you are not 100% sure on plotting a quadratic graph, again, it's worth looking back. I've done a video on it. It's worth looking back and getting your head around how to plot a quadratic. Now, sometimes you'll be given a graph, a table, sorry. So I'm going to make a table here if I don't have one. -2, -1, 0, 1, 2. And I'm going to now substitute in the values to work this out. So x is -3. So I'm going to substitute in -3 first. So -3 squared, because I'm saying x is -3, plus x again, and x is -3, -2. First thing to remember is -3 squared, that's a -3 squared, which becomes 9. Plus -3 means -3, -2. So 9 minus 3 is 6. 6 minus 2 is 4. So this point becomes 4. Okay, let's substitute in the next value. So the next value here is -2. So I go -2 squared plus -2, -2. Lots of 2's involved. -2 squared is a positive 4. Plus -2 means -2. -2 is 0. 4 minus 2 is 2. And 2 minus 2 is 0. Next point. Substituting in -1. So we go -1 squared plus -1 -2. This becomes 1. -1 -2 is also 0. Is -2. 1 minus 1 is 0, -2. Substitute in 0. So let's do the next one. 0 squared plus 0 minus 2 is -2. Last couple of points, a little bit easier because these are now positive. So we're going 1 squared plus 1 minus 2. Well, 1 squared is 1 plus 1 minus 2. Well, 1 plus 1 is 2. Minus 2 is 0. And finally, the last point is 2. So we go 2 squared plus 2 minus 2. That's 4. 4 plus 2 is 6. Minus 2 is 4. So what we've now got is we've got some coordinates that we can plot. So let's quickly plot this quadratic graph first of all, this U-shape. So we go -3. Remember, you're going x first and then 4. So -3, 4 is there. Next point in green, -2, 0 is on the line. -1, -2 is down there. 0, -2 is there. 1, 0 is there. And then 2, 4 is there. So let's now, I'm going to do this one in blue. So I'm going to do this line in blue. So what I now need to do is join these lines up, these points up, smoothly as I can. Going through the points with a smooth curve. Okay, so that's my quadratic graph. Now let's plot this one using the same logic as the one we just did. We go to 2 on the y-axis because that's my y-intercept. I go across 1 and I'm going up 1. And be careful here because what I've done on this axis, 2 squares represents 1 here. So you go across 1, up 1, across 1, up 1, across 1, up 1. And then go the other way, across 1, down 1, across 1, down 1, across 1, down 1. And you can see I end up with a nice straight line again, going through those points. And now what you can see is I actually end up having 2 crossing points quite clearly labelled there. And the coordinates now of this are 2, 4. And for this one, it is -2 and then 0. Okay, remembering that's your x value, that's your y value, that's your x value, that's your y value. Now with this, you will end up having 2 solutions. You'll have x equals something or something, y equals something or something, and this is why, because it crosses at 2 points. So the first one, x is equal to 2, because that's that point there, or -2. And in the next one, y is equal to 4 or 0. Okay, so they are your 2 solutions when you have a quadratic with an x squared plus x minus whatever it might be, or it might just be an x squared plus or minus something, and then you have your diagonal line as well. So final one we're going to talk about now is something that looks like this, when you actually end up having a circle as part of your graph. So first thing to identify, this red part here, the graph of x squared plus y squared. If you see x squared plus y squared, it will give you a circle on your graph. Okay, now this has been drawn for you. Sometimes it won't be, so in your exam, the way you get it is you square root the end value here. So in this case, 16 is the end value, so square root 16 to get 4, and that becomes your radius. So you would put your pencil and your compass, open it up to a radius of 4, draw a circle around the centre. Then the next part is I need to rearrange this to get it in the correct format. So let's go back to what we did at the start. It would become 2y is equal to 4 plus 6x, and then divide it all by 2. Y is equal to 2 plus 3x. Okay, we need to now plot this line, but let's just look at the wording of this. It says, by using the graph, find estimate, so more than one solution, for the solutions. So it has to be an estimate, so it's not going to be exact values, because your graph will be probably slightly different to somebody else's, depending on how you interpret it. So this is your y-intercept, remember, so we go to 2. And the gradient's now 3, so I go across 1 and then up 3. So it's quite a steep graph this time. Across 1, 1, 2, 3. And then to go the other way, across 1, down, 1, 2, 3. Across 1, down, 1, 2, 3. So we end up getting those points down there. Across 1, 1, 2, 3. That one would go off the graph. So joining those points together, that's my straight line. And again, what you are now looking for are the points where it crosses the other graph. Now, if I look at this, remember this is an estimate, so it doesn't say exact. I would say that's about 0.6 or 0.7. Let's call it 0.7. And then your y is probably 4, maybe 3.9 potentially. But that's your x and that's your y. And then down here, looking at this one, if I read up here, that's about minus 1.9, possibly 1.8. And then here, that is about minus 3.5. So again, you'll have x equals something or something else, y equals something or something else. So in this case, x is equal to 0.7, x is equal to minus 1.9, and y is equal to 4 or minus 3.5. In an exam, there would be a range that you would be allowed for that, because it says estimates. The range that you'd be allowed would depend on how in depth the graph is and how detailed the axes are, but you want to try and make it as accurate as you can. Okay, so hopefully that helps you. That's the different styles of solving simultaneous equations graphically you need to get your head around. Sometimes you might just be given the graph straight away and you just need to interpret the crossing points, and the crossing points are your solutions. Hope you found that useful. Hopefully it will help you, and I will see you all in the next video.